Hey, math friends. So our learning target today is I can simplify expressions with negatives and exponents. So let's first talk the language of what is an exponent. You know what a negative is. We've been working through integers for the last few lessons. So let's tackle that concept of what is an exponent. So you've heard of powers before. So basically an exponent is a power. You've heard something like 3 to the second power. So that's kind of what we're going to work on today. So the exponent tells you how many times to multiply the base. So if we talk definitions here, the base is 3, the exponent is 4. And again, the exponent tells you how many times to multiply the base. So the exponent says that we need to multiply 4 times. What are we multiplying 4 times? The base. So that becomes 3 times 3 times 3 times 3. Now I'm just going to ask you to expand that right now. We don't have to get the value of that. Just let's work on expanding so we understand what does the base do, what does the exponent do. Again, the way that's stated is 3 to the 4th power. Likewise, in this next example that's listed, we have 1, 2, 3, 4 as the exponent, because the exponent tells us how many times do we multiply the base. So we're going to multiply the base 4 times. And of course, that would have equal 16, but that's not the kind of what I'm working on right now. I just want to make sure you understand the expansion process. What does the base do? What does the exponent do? Now, this next one's a little bit tricky. It says 5 to the 0 power. So how many times are we multiplying the base? 0 times. So we don't even put a blank down because that's not what's happening. Now most kids would think that the answer to this would be just 5 because it's 5 to the 0 power. But the proof of that is really about patterns. So if we break it down here, that we have 5 to the 0 power, we want to know the value of that. Most kids think 5. We know that 5 to the 1st power would be 5. So 5 to the 0 power cannot be. They cannot have the same value. 5 to the 2nd power is 25. So what about 5 to the 3rd power? Might be hard to do in your head, so I'm going to help support you on that, but that's really 5 times 5 is 25. Times 5 is 125. So if we talk patterns here and we work down, we divide by 5, we divide by 5, we divide by 5. So 5 to the 0 power by default and by mathematical pattern would have to equal 1. And that in fact is what it does equal. If we continue that process, mathematical proof, we divide by 5, then 5 to the negative 1st power would be 1/5. 1 divided by 5. 5 to the negative 2nd power would be, divided by 5, 1/25, and so on. That pattern would continue. So the key of this entire little side page that I created is that anything to the 0 power equals 1. So what does 5 to the 0 power equal? 1. Not 5, 1. We will continue to practice that as we work. So if that's confusing to you, I understand. Now, in the you try section, we're actually going to do that together. I'm not going to ask you to solve those. I don't want you to put in your calculator. I want you to understand what is the purpose of the base, what is the purpose of the exponent. So, example 1, 3 to the 2nd power. That means we need 2 of those because exponent tells us how many times to multiply the base. So that would be 3 times 3. Of course, that equals 9, but let's just work on that expansion. So what happens if we change that exponent to a 3? 1, 2, 3. So that's 3 times 3 times 3. Of course, that's 27 because 9 times 3 is 27, but that's what the expansion looks like. So if you want to pause at any time and try in your own scratch paper, if you have access to a whiteboard and you want to work some of these out, that's fantastic. So we're going to keep plugging around along here. The exponent here is 4. 1, 2, 3, 4. So we have 10 times 10 times 10 times 10. Of course, that's 10,000, but right now I'm just asking you to kind of just show the concept of what happens. Okay, example 4 would be, we're going to multiply 4 times the base of 5. So that's 5 times 5 times 5 times 5. And that would be 625. So example 5, that newest concept that we've not seen before, most likely you've not seen it before. What about 7 to the 0 power? How many times are we multiplying the base? 0 times. Because of patterns, 7 to the 0 power equals 1. 1. Not 7, 1. So that's going to be kind of one of those things that will be in our summary for today's work. And sometimes we forget about how do we do that. So simplify expressions. You've heard of PEMDAS, or please excuse my dear Aunt Sally, before. We're going to use that same skill in our work today, and we're going to use it with exponents. So first step would be parentheses. Any parentheses we have to do first. We do everything inside the parentheses. Exponents or powers comes next. Multiplication, using those parentheses most likely, or division. And we do that left to right. It's a tie. They are tied. They are equal strength. So as we read from left to right, we will do the one that shows up first. And then addition, subtraction. Again, that's left to right. So that's what we call PEMDAS. When you know that as, please excuse my dear Aunt Sally, or PEMDAS, order of operations. The same old order of operations you've been doing forever. What's going to be a little different in our work today is there will be some negatives in there, and then we will be doing a little bit more with exponents. So PEMDAS with exponents, negatives. First step here. This problem, do I see any parentheses? No. So parentheses are dead. Do I see any exponents? Yes. So if my exponents are here, let's be a different color, but are here and here. We know that 3 to the second power, and I'm going to write these out just because we just talked about them, but you don't have to write all those steps down, would be 2 of those, 3 times 3, plus 5 times 5. That's really what we have. The expansion would say that's 3 times 3 plus 5 times 5. Now, of course, order of operations is do all multiplication and division before we add and subtract. So that would become 9 plus 25. That's 9. We don't even have to make a triangle because it's positive, positive. And that becomes 34. So you've been doing PEMDAS since elementary school. That value becomes 34. Okay. So what about our next example? In our next example, PEMDAS says do the parenthesis first. So I go inside and take a look at this parenthesis. And inside of there, I have a subtraction problem. And I'm going to show my work inside of here, and then I'm going to keep erasing, which is the beauty of the smartboard that I'm able to do that, or the slate that I'm using right now. So tug of war. 3 people show up on team positive. 8 people show up on team negative. Who's stronger? Negative. How many extra people? 5. So the result of that parenthesis would be -5. Again, I'm going to erase that. And I'm going to say that inside that parenthesis, this results in -5. When we have a negative base in math, we want to make sure we keep a parenthesis around that negative just to kind of protect it. When there's an exponent on the outside. See this little exponent on the outside? When this happens, let's keep that parenthesis there around the base. So if I haven't used it, I'm going to drag it down, drag it down, drag it down. Drag it down, drag it down, drag it down. And then this is a multiplication sign, right? There we go. So now, parentheses, dead. Exponents are next. So I'm going to expand this out. This really is saying that I need to multiply that 2 times. What am I multiplying? -5 times -5. So that's the only step I'm going to focus on right now. is that negative 5 times negative 5. So negative 5 times negative 5 is 25. Why? Because the triangle says that it is. So we have a negative 5 multiplied by a negative 5. If I haven't used it, drag it down, drag it down, drag it down. Okay, good, 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 good. All right. So all exponents are gone. Multiplication and division is next. We know that they are tied. As I look at this problem, I see both. I have both division and multiplication. So I'm going to work it left to right when that happens. Left to right. So we have a division here. They're both positive, so I don't need to make a triangle. That's 4. If I haven't used it, drag it down, drag it down, drag it down. And 4 multiplied by 25 is 100. Again, I don't need to make a triangle because they're both positive. So the results of this problem at the very beginning, way up there, and you can pause and try it yourself, would be 100. So order of operations. All right, we're at the 11-minute mark right now. I try to stay under 20 minutes. I know that you're probably like, seriously, 20 minutes? But yes, we know that that's how it would be in during a class, right? All right, so let's take a look at what happens when we have this fraction bar. Well, we still use PEMDAS, but we're going to do the entire numerator, get a value. Then we're going to do the entire denominator, get a value, and at the very last step, we will divide. So let's take a look at the numerator. The numerator has negative 7 multiplied by 3 squared. There is a parenthesis on that negative 7, but we don't really need it there. It doesn't really do, there isn't anything to do inside that parenthesis where that negative 7 is. So the result of that is really negative 7, and I can keep that parenthesis there, that's fine, times 3 times 3. That's what that says. What is 3 times 3? Well, 3 times 3 is 9, and I don't need a triangle there because they're both positive. So we're going to end up with a 9. That will become a 9. 3 times 3. In the denominator, we have a subtraction sign. So we have a positive 2 and a negative 5. The result of that would be what? Well, we have positive on the 2. We have negative on the 5. So the result of that would be negative. And how many extra players? 3 extra players on team negative. So if we clean up the rest of this problem, and I'm going to erase this so we have some space, let's talk about the numerator. This numerator is 7 times 9. Using your finger little method that you guys use with your 9 multiplication would be 63. And using a triangle for that, we would have negative on the 7, positive on the 9. The result of that would be negative 63. That's the numerator. That's the numerator. Divided by the number that's on the bottom. So we're going to create a new triangle here, new triangle. And we have negative on the 63, negative on the 3 is positive. And now maybe this might be a little tricky for you, but how many 3's go into 63? Well, 3 goes into 6 2 times. Drag it down, drag it down, drag it down. Whoops, didn't mean to do that. How many 3's go into 3? 1. So we know that 3 goes into 63 21 times. So the result of that expression is 21 using the order of operations. So maybe you should try that again if you struggled. Rewind it, try it yourself. Keep making attempts. All right, what about this next one? Same idea. We're going to do everything on the top first. So let's just look at the top first. Okay. So on the top, we have, the very first thing we have is negative 5 times negative 5. Negative 5 times negative 5. That becomes triangle. Negative times negative is positive 25. Positive 25. Okay? So there's my exponent. Then we have plus 2, plus 2. Easy peasy lemon squeezy in that numerator. That was like 27, right? So I might just rewrite that right now. That's 27. So I'm going to write that there because of space. Oops, I need the eraser. This is not as easy as it looks, friends. Okay, so 27 is the numerator, 25 plus 2. The denominator, oh boy, I see an opposite happening there. Because it's subtraction, we're going to tug a war. All right, we have 6 players showing up on team negative. And then we have this guy in the back. However, it says take the opposite of that number, which means that now that's a positive 9. Oh boy, I made a mistake here. Let's go back. Let's go back. Let's start all over because I have a clear mistake here. We have try that again. 6 players on team negative is what I should have done. I apologize for that, but that's good for you to see those mistakes that are made. This now says the opposite of that value. That's what that sign means, opposite. So we are going to change that into an addition problem. So now those 9 players end up on the positive team. So positive team clearly is stronger. How many extra players? 3. So now this is a division problem. Don't even really need to set up a triangle for that because it's positive divided by positive, which is just simply 9. Simply 9. Okay. So what about multiple steps? All this stuff going on in the same problem. What happens now? So we're still going to use PEMDAS. We're going to still work through those steps. And we're going to take it one thing at a time. So the very first thing I'm going to do is this parenthesis. All I'm going to look at, and just that parenthesis. So that is a tug of war. We have 6 players on the positive team. We have 10 players on the negative team. So the negative team is stronger by 4 players. So the result of that is -4. So the result of this is -4. I'm going to drag this addition sign down. Now, the next thing that we're going to do is the exponent. So let's go look at that exponent. It's way over here. That exponent is saying that we have to multiply 4 2 times. Not 4 times 2. We have to multiply 4 2 times. So that would be 16. That exponent at the very end is going to be 16. Okay. So now, let's drag the rest of this down so we can kind of make sense of it. Look, can I move this over? There we go. Perfect. Let's drag this down. And then we'll just continue to do steps. We have multiplication here, drag it down. And then we have drag it down, drag it down, drag it down, drag it down. Good. So what's next then? Well, we've killed the parenthesis. We've killed the exponent. This parenthesis here simply means multiply. So that would be our next step, is to multiply, since I don't see any division. That's a triangle problem. And we have negative divided by negative is positive 27. Positive 27. If I haven't used it, drag it down, drag it down, drag it down. This is a 0. Okay. Now, addition, subtraction are tied, so we work left to right. So for this problem here, I'm going to tug a war that. I have 27 players on team positive. I have 4 players on team negative. Who wins? Team positive does. How many extra players? 23. If I haven't used it, drag it down, drag it down, drag it down. Okay, so drag it down, drag it down, drag it down. All right. So here we have 23 minus 10. Of course, you can tug a war that. You'll get the same result, but 23 take away 10, of course, is 13. Drag it down, drag it down, drag it down. And we end up with 29, which you could tug a war as well. Now, I get that we're at the 19-minute mark. We might need a little bit additional time on this particular lesson because it's super important and it's pulling all those skills in together. Okay, so what I'm going to have you do is I'm going to have you try just the last problem on this screen. Just this last one is all we're going to do, this one right here. So I want you to pause the video right now, and I want you to give that problem a shot. So if you haven't solved it yet, I want you to give that problem a shot. All right, so everybody should have given that problem a shot. You should be, we're going to take a look at your answer right now. All right, so what do we do for this problem? Well, first thing we do is we are going to take care of that exponent because we have that exponent in the numerator. So this is our last problem of the day. Let's stay with it. This is saying that we have -3 times -3. -3 times -3. What is -3 times -3? Well, it's 9. Positive 9. Because it's a triangle, right? Negative times negative is positive. Then we have a +1. Well, 9 plus 1 simply is 10. You could tug of war that, but not necessary. Now in the denominator, this is a tug of war because of that subtraction sign. So let's put 6 players on team negative. And this sign, of course, means opposite. So we're going to chop, chop. So now this becomes positive. Who's stronger? Negative. How many extra players? 5. So the result of the denominator is 5. The very last step then would be to make this triangle because it's a division problem. So we have a positive 10 divided by a -5. The result of that is negative, and 10 divided by 5 is 2. 10 divided by 5 is 2. So the summary of today's lesson is that you basically need to use PEMDAS. And just reminder that when multiplication and division are in the same problem, you go left to right, left to right. And if you have a base that's negative, reminder, it's helpful to keep it in a parenthesis. So that means I need 2 of those. That's -3 times -3, which is +9. So just be aware of that. That's a triangle. That's it for today, guys. Have a glorious night. Great job. Way to stick with it. That was a long one. You did an awesome job. See you tomorrow.